أخبار اليوم.
And now we are going to discuss the last and the final question, question 5. It starts with mention the results based on increasing the pressure on a gas while cooling it to a very low temperature. What happens? What happens? What are the results when you increase the pressure while cooling the gas to very low temperature? Yes, van der Waals effect takes over, and the molecules of the gas come closer and closer to each other till the gas is condensed. Condensed here means liquefied or solidified. The next part is replacing the slip rings in the generator by a commutator. When you replace the rings by a commutator, you obtain unidirectional current. Current in one direction, but its intensity varies from 0 to maximum to 0 and so on. The third part in mention the results based on passing a photon of energy h nu equals E2 minus E1 through an excited atom before its lifetime is over. Yes, stimulated emission. That is very important and very famous. Stimulated emission takes place, the atom is transmitted back to a lower energy level, emitting a photon of energy h nu equal E2 minus E1 in addition to the incident photon. That is stimulated emission. The fourth point here, the existence of high potential difference between the terminals of the fluorescent lamp. That is in induction chapter. In the chapter of induction, we have one application for self-induction, which is the glowing of the fluorescent lamp. So, as a high potential difference is applied to the terminals of the fluorescent lamp, electric discharge happens through the inert gas inside. And the ions of the inert gas, as they collide with the fluorescent material lining the glass walls of the lamp, visible light is emitted. It glows, the gas glows. Finally, passing an electric signal through the grid in the cathode ray tube. So very important here, the word grid. So the question is about cathode ray tube, not about the electric signal. The word electric signal is repeated in different places or different positions in the syllabus. But we are going to talk about cathode ray tube, so remember that. When electric signal is passed through the grid, it varies the negative potential of the grid, controlling the intensity of the electron beam, controlling the intensity of glowing on the screen, and that to form the image. The second part in the fifth question mentioned 3 ways to improve the efficiency of the transformer. Very easy and famous question. We can, to improve the efficiency, we can use wires made of copper to lower the resistivity of the wire material, and we can use soft iron core, since soft iron consumes low mechanical energy to arrange its magnetic particles. We can shape the soft iron core in the form of thin laminated sheets insulated from each other. So these are the 3 ways to improve the efficiency of the transformer and reduce the loss of electric energy through the transformer. The second part in the fifth question, when does each of the following quantities equal 0? So the photon mass, yes, right. The photon mass becomes 0 at rest, when the photon is at rest. The second part, the intensity of radiation of a glowing source. Glowing source, that is Planck's distribution. Glowing source, that's Planck's distribution. And the intensity of radiation becomes 0 at very short wavelength or very long wavelength. The third and the last part, the magnetic force acting on a straight wire carrying an electric current placed in a magnetic field equals 0. Yes, right. When the wire is placed parallel, yes. Force acting on a wire equals BIL sine theta. So one of these should be 0 to make F equals 0. In that statement, there is a magnetic field. So there is beta. There is a wire, so there is length. There is a current, so there is I. So we have BIL. So the only probability here is sine theta. Sine theta equals 0, and that happens when the wire is placed parallel to the direction of magnetic flux. Finally, the last part in the fifth question and the end of the exam, the table below records different values of multiplier resistance Rm that is connected to a moving coil galvanometer to change the maximum potential difference it can measure. So that is the multiplier resistance value, and that is the maximum potential difference can be measured after connecting the multiplier resistance. Plot the graph representing the relation between maximum potential difference V on the ordinate means y-axis, and Rm, the multiplier resistance on the abscissa, x-axis. So from the graph, you need to find that from the graph. The maximum current intensity measured by the galvanometer, that is Ig. The resistance of the galvanometer, that is Rg. So we are going to find Ig and Rg. Let's have a look about the answer. So that is the answer. The graph, when you plot the graph, please write the quantity and its unit, the quantity and its unit, and equal spaces, equal values, equal spaces, 0, 500, 1000, and so on, 0, 5, 10, 15, 20, and so on, and the points are joined through a line. First of all, we are going to find the slope of line. Slope of line is delta V over delta Rm. So delta V over delta Rm equals 10 from, as you see, 5 to 15. You can choose any 2 points, so that is 10. And from 400 to 1000, 400, so the difference is 1000. So the slope of line equals 0.01. That slope of line equals Ig. By the way, in this, Ig is the slope of line, so it equals 0.01. To find Rg is the galvanometer resistance. You have to know this point. This point is in 0. The line doesn't intersect the y-axis at 0. There is a value, that is 1 volt, because 1, 2, 3, 4, 5. So that is 1 volt. 1 volt is Vg, that is Vg. On axis of V, that is Vg. So Vg equal 1 volt. Vg equals Ig Rg. So 0.01, we got it from the slope. So Rg can be calculated equals 100 ohms. That is a very important graph, and that is the end of our exam. Best wishes to you all.